So just like everything else, the back gear assembly is going to get cleaned before it gets put back on. And I noticed that it engaged very hard. The way it engages, there's this lever that's mounted on here, and you can see how it's on an eccentric. So as you pull the lever one way or the other, it will move these gears towards the back gear set on the drive shaft, or it'll move it away. And it spins nicely, so that's not a problem, but just the actuation is the sticky part, and you just want it to operate nicely. You don't want to fight back gear. You shouldn't have to say, oh, I'm not going to bother changing the speeds because it's too much of a pain in the ass. You should just be able to throw it in gear and be done with it. So I'm going to clean up this part of the shaft, and that should allow me to drive it out. Then I can clean everything up and put it back together. Now here's the back gear assembly all installed. This screw here is actually a tension adjustment, I guess you could say. There's a little brass or bronze puck behind this, and this jams up into the eccentric that we just took out of here. And the reason is there's no latch or detent to lock this into and out of back gear, so it just kind of relies on friction. Now right now you see it's disengaged, but if you push the lever down, it will engage the gears. I'll do that again for you from a different angle. Disengaged and engaged. So you just tighten this so there's just a little bit of drag, and that should just be fine. This little bolt here, that is for a gear cover. Out of curiosity, I did a quick rough measurement of the gear reduction here, and this reduction is roughly 3 3/4 to 1. So when this pulley rotates around 3 3/4 rotations, this shaft that goes to the spindle rotates just once. And also there's a further reduction in this bevel gear here. So right now this is locked in direct drive, but back gear is also locked in, and you'll see that it's all locked up, it won't move. But if I disengage the direct drive and rotate that pin so it stays out, now you can see how the gear reduction works. Notice how this gear is spinning much faster than this one. So I added a couple more little components. There's a gear guard for the back gear. There's a gear guard for the front bevel drive gear. I did have to add a little wire shim there because it was falling down too far and hitting against the bevel gear in there and grinding, so I shimmed it. And the last component I added is this little stop here. This thing is pretty cool. I'll show you it in action later on when I get this running. But this little finger here, you can loosen this and adjust it up and down. This finger, as this is traveling downward in power feed, it will hit this lever, and this lever is what disengages the power feed, so it'll shut itself off on its own. You don't have to worry about shearing a key or throwing a belt if you run the drill into the stop, because the stop is meant to shut off the power feed, which is a pretty cool feature. The other interesting thing about this stop, I'm not sure what to think about it, is that you can probably see it. This front piece can't be flipped side for side. This hole is further out that way than this hole is. Also, these screws can't be flip-flopped. One head is ever so slightly larger than the other. So was that intentional, or was that just because of a hand fit, or these were drilled by hand and thus they're not equal? I don't know, but I thought that was interesting. So I just cleaned up the table before I put it on, And I've commented on things like this before, and I will continue to, because I just think it's really cool, and it's the piece, it's the material talking to you and telling you a story. Firstly, of course, we got a bunch of drill marks from previous users. This is quite a large hole. This looks like possibly a custom-made hole, a clearance hole for some job that was done on it. But what I really wanted to point out was, since I sanded this just by hand, it brought out the high points but it kept dirt in the low points. So as a result, you can see these zebra marks, and in fact I can feel them with my finger. They're quite noticeable. But notice how they're only on one side of all of these holes, but not the other. And the way I figure it, this is because when this was turned on a lathe, the back part of it here was held in the chuck, and then a facing tool was brought across here to face it nice and flat. And of course, in a lathe it will be rotating this way. So when that cutting tool was going through this interrupted cut here, it would hit this edge, and I imagine it must have vibrated a little bit. Maybe the setup wasn't quite tight, or it was a dull tool, or who knows what. But this is evidence of that. It was probably a pretty heavy cut too. I'm sure they weren't taking their time on this. They just, you know, it's not a super precision surface. It's just a drill press. It's not like it's a table to a Bridgeport milling machine or anything like that. So the result are these zebra lines coming off it. I just thought, again, that was something interesting. So I cleaned the motor up, shot some lubrication into the 2 lubrication points there, and I wired it up. The wiring is super crusty. I have it set up now just so I can hear it run and show it to you guys, but I have to replace this cable here and the other one too while I'm at it, because this is that old cotton insulated wire that there's rubber on the inside, but the rubber is so deteriorated it just snaps. And as I was bending the wires to get it into that junction box there, I heard the insulation just crumbling. So it's a little crusty. I really do like this box though, this on-off switch, so I'm going to keep this, but I'm just going to replace this wire. Now in front of us here are the 2 drive belts. This is the main drive belt, and this is the power feed belt. They're both leather. They're both in marginal, half decent condition. You see there's some checking, but the inside here is actually pretty decent, the friction side. And the same goes for this belt here. So I'm going to reuse these, but like I mentioned before, I'm going to have to chop off a little bit and relace it. But again, I'm just going to set it up right now as it is, just so I can listen to it run again. Well, it's alive! The belt is extremely loose, and it actually doesn't go at all unless you give it a little bit of tension first. So I got it in the lowest speed and also the lowest feed, so you can watch everything work. And I'll fire it up and show you. Once it gets going, you can let go and it keeps itself spinning. It's in back gear. First gear, or first slowest speed on the stepped pulley. Look how slow that thing is spinning. 60 RPM maybe? I'll show you the power feed. So you see this is constantly spinning, but it's disengaged from this gear. So when I want to engage it, now it's in. And this is spinning, albeit very slowly. Let me show you. Just watch the inch marker go down. You see that? That is a very slow speed. And this right here is the latch out. When the stop on the quill pushes the stop lever, or if I manually press the lever, it'll disengage this and this whole assembly will pop up. So I'll push it now by hand. Disengaged. I'll push it down. Gotta wait for the tooth to come around on the gear. Wait for it. There we go. Now it's engaged and turning into power feed. And once again, I'll kick it out. I'm just mesmerized by this thing. Just listen to it. It's so nice. Even those straight cut gears aren't too loud and clanky. You got all sorts of whirligigs and doodads spinning a thingin' around. Now this ratchet here, I couldn't quite figure out the purpose of it, but I believe what it's for is when you're in power feed, you can turn that hand wheel by hand and advance your drill bit down more rapidly in case you start your power feed too far up and you're waiting for it to cut material. So let's give that a try. So it's in, wait a minute, it's not in power feed. Okay, so it's in power feed now. Now if I want to advance it faster, yep, and I can let go and it just carries on its own. That's a pretty nifty feature, huh? Well everybody, that's it. I hope you enjoyed these videos. I sure enjoyed making them. I'm so excited about this drill press. I can't wait to get this belt laced. Both of them actually. The power feed belt, that's a little better. It's a little tighter, but it's still maybe a little bit too loose for my liking. But anyway, I can't wait to get that belt done. And then I can actually use this for some drilling jobs. I'm definitely going to make a drilling video, a power feed drilling video. I'm just looking forward to that. Just hogging out a real big cut. I'll see if I can find a big drill bit, and we'll just have some fun with it. So anyway, thanks for watching. I hope you enjoyed this. I sure did. Make sure to leave a comment down below if you feel so inclined. Make sure to hit the like button if you enjoyed this. Hit the subscribe button if you haven't already. And if you want to see more of these videos, see more videos of me restoring and reviving old, antique, forgotten machinery. So thanks for watching everybody. Make sure to stay tuned for more.